To start my talk, I'm going to give you some general examples of how we should think about data and AI. Um, but I'll use some examples of Norway. But I want you all to really think about. Often in Norway, there's a lot of technology development, and it's very large and it's very big. But when we think about AI and the use of AI, it can be the smallest thing. So if you have an oxygen sensor, you can use AI for predictions of when it's bad. You can start integrating it into something about the environment around and do predictions, linking things. So as I go through here, I also want you to um, think about, let's see if I can make this move. Next slide. Is to think about, so in your companies or in any organization, it's really important to be able to use AI. You really need to have some certain foundations. And I think the most important thing is the data. And if you don't have good data, you're not going to get anywhere. We've had many examples of this in Norway where just the data between companies and this, you won't be able to use it just because there aren't the same standards. So collecting the data, so you should think about how that is. And if you are thinking about new type of sensors or new type of equipment to monitor, one has to really think about, okay, how do I deal with that? What kind of infrastructure, what kind of security? So I can talk a lot about this, but I don't think that's the point today, is really to go through all these different details. But really, data is the foundation. And then you're starting to get into the data analytics and visualization. And here, once you have good data, then you can really start using applications that are already there, or you can build applications that are specific for you. And this could be either some kind of digital twin of a site or even of your business in that case, and use AI to then improve that. And with good visualization, then you can make easy decisions. And I'll try to show you some examples of that later. I would say one of the biggest bottlenecks I find today is actually the collaborative data sharing partnerships. So often what we need to advance innovations that we're trying to build in aquaculture today, it relies on more than one entity, whether it's two suppliers or if it's a supplier and a fisherman or an aquaculture farm. And often there aren't good data sharing partnerships in place to allow that data to be used in the best way. Often you don't get the the metadata, or you don't have other things that can really improve that value. So I would say for me today, this is probably one of the things I'm pushing the most, because I see companies that are coming with a new supplier and they say, okay, I can do this. And another supplier is coming to say, I can do that. But instead of going together and collaborating, they are trying to do what the others are doing. But if they collaborated, you would actually have these innovations and more holistic solutions on your doorstep much quicker. When we think also about using AI, so the digital transformation, so within a business, a company, from the worker, from the fish farmer, all the way to the CEO, there's a lot of bottlenecks on how to use that. Are we going to use the AI? Is it going to give me value, but am I going to lose jobs because now they're going to use smart feeding? But how can the CEO use AI? to have a better understanding of their operation. So there are a lot of these levels where if you're going to make this work, everybody needs to be able to learn how to use it. And I think I talked about some of this, and I'll look forward to some questions around that later. And also, when you're coming into the use of AI, the business transformation. So how you think about how you use your data and AI operational models will be changing just because you're doing it in a different way. We see, I mean, these are things that are very general for everybody. The challenges that the aquaculture sector has today, whether it's fish health and welfare, aquaculture impacts on the environment, feed sustainability, climate change and extreme weather impacts on aquaculture, efficiency throughout the value chain. So how going from how do we ensure that we are moving feed in the most efficient way from one place, or the fish for that matter, and data-driven management and mitigation. I can say that in the fish farming industry in Norway today, it's just starting to get to where data is all getting to the same um, platform. So I work with some companies that are just getting all their data into Snowflake. So this, for the first time, they can go from to use the data from freshwater and sea to water operations and do AI on it, because before you never couldn't, because all the data is in silos. So it's all fragmented data coming from different systems. So these things are just coming now. So I think this is um, something that's going to really help the industry. Um, in Norway, especially, but in other places, we see that there are new production systems that are evolving to help the growth at the same time to try to protect the environment. And we have everything from RAS to offshore to semi-closed to submerged to integrated to IMTA. Um, and all of these type of systems really rely on more data, more um, uh, the word I come up with Swedish words, and that's not, and English is my mother tongue, so that's but surveillance of the operations. And so you see that there's a lot of work going into machine vision and AI and robotics to actually make these things successful. Um, and we can even go into, a lot of these big offshore concepts. And I have this figure, you guys are all familiar with this maybe, or the concept, but the little red triangle is what we used to see in our sea cages. So we used to be able to see 6 to 7% of the sea cage, the fish inside the sea cage. Well, today we can maybe see 0.2. And so we rely so much on cameras and machine vision to know what's going on with our population. And we are doing it today in some cases for doing certain things, and I'll talk about those. But I think that what we'll learn is that one system isn't going to be enough to be robust and reliable. You're going to have to integrate some of these systems for smart feeding or others to ensure that you don't make large mistakes, I would say. So if we look at aquaculture in Norway, we see these a lot of the feeding today is it's still manual feeding, so it's still using screens and cameras. They're starting, so a lot of the suppliers now are coming with, I have the smart feeding solution for you. I think they all are, they're good. They give a lot of important data and can give support to the farmers, but they're not robust enough yet. I haven't seen any that I feel I'm totally confident yet. So, but I think they're coming. But I think that's because having a camera in one place to look at uh, fish around the feeding isn't necessarily um, all you need to optimize the feeding for the whole population inside the cage. So if we just look very quickly at some of the applications of AI in aquaculture. So um, it's everything from, the real-time information of the environment and the fish behavior. So this is part of, by having that real-time information, then we are able to start being able to do predictions and characterizations, use AI to understand what it means. Um, we're not there yet, but it's coming, and more things are coming. When you're also thinking about for welfare, there are going to be more and more welfare automatic real-time information. But that's going to use machine vision and AI to give you those type of thresholds. Automated biomass measurements is a critical thing. Feeding optimization um, and automation is really going to have a major impact. I mean, that's why so many people are doing it. We know that if we can optimize how we feed, we're going to have less feed spill, less environmental impact. So it will be a win-win. And anything you can do to improve that, I think, is a excellent thing. Early warning of disease and parasites and their spreading. So, it's everything from um, so when I talk about these things, sometimes I'm talking about, let's say, in your one cage, to understand early warning of disease, whether you see it with machine vision of a camera, or you see that the behavior through hydroacoustics is different, or whatever case you use. Um, that's important for that cage, but it's also important to have that information to be passed on to your neighbors, to everybody else in the area, so that you can mitigate these types of things as quick as possible. Today, and if you go around in Europe in all different kinds, many of these things aren't happening today. Um, which they should. And a lot of that has to do with no requirements, or the data isn't there to where you can share it. It's not in a place that's good enough to share. Um, let's see. Climate change and harmful algae bloom predictions and warning. For northern Norway and other places in Norway, this is a major thing. Um, and we just saw in last fall, one of the companies, they lost 300 million. But if they had had some better early warning, they might have owned one day early warning. They maybe saved 150 million out of the 300 million, just because they had one more day to react. Um, that's coming. There's all kinds of new infrastructure and equipment operation for condition monitoring. So, I mean, really understanding how your equipment is doing at all time and predicting when it needs to be changed or when you need to do something. That will help efficiency, but also losses. Um, we're doing work a lot now on energy optimization. So how do we optimize the use in RAS systems? So how do you use your blowers? Do you have to do that all the time? Often they're just put on full blast because that's what it is, but actually you don't need it all the time. So finding ways where you can use AI to adjust to the environmental conditions, what the fish need. This is something that we work for, and where AI can really help. Um, we use it today for um, parasite removal. I'll give you an example of that later on, but also for predator warning. So in Norway, we have sharks that come and eat the dead fish on the bottom of the cages. And so you can use different warning systems that can tell you that, okay, now you need to do something. How do you can use AI to improve your whole rearing protocol. By having all your data in a place, you can then be able to see what things have I done right over the years or in this type of condition. And AI can help you manage that. And in Norway, they're starting to do that, but they have to have their data all in the same place. Logistic efficiency, again, these things matter, and that also relies on being able to have the data and then be able to add AI models to that to improve it. And then product traceability from farm to fork, that's maybe less AI than data sharing, I would say. Just a couple quick examples. Um, I so if we look at what we're doing today and where the industry wants to go, at least in Norway, I think you can see that this is applied in most places, that you have different health and welfare threats, and how do you monitor them? So how do you see them? And often you're using AI today to help identify them, but also to be able to use AI for the mitigation. So a quick example, I think I jumped to the next slide as an example. So here you can start using satellite information. You can use data from other databases. You can use drones or sources from the sites to give you really specific early warning of what it is. And that's, a surveillance AI. But then um, in the north, they're starting to share what sites they could move fish to, or what well boats are available, or what slaughtery could have space so you could emergency slaughter fish so they're not wasted. And to have them into databases to do this. Today, they are calling up on the phone and trying to find a solution, where actually, if you were in a network and you had this, you could use AI to actually speed this process up. Um, the integration of biology, environment, and operation for robust decision support. And I think I think I won't go into as much detail as I have so far, but one of the things I wanted to say here is that, you know, what I talk about is any fish. So machine vision and AI can be used in whatever type of situation you are. What kind of aquaculture? And I mean, it can be for kelp, so for the growth and prediction of when the harvest of the kelp should be is the same thing. You can use machine vision and AI for that. But it's complex. But today, the way the machine vision and the tools that are being developed are, they can adapt to all species quite easily now. Before it was much more 1 or 2 years ago, it was much more complicated. But things change so fast. These things are happening very quick. Um, I use Aquabite as one of my favorite examples of how you can use AI to do reporting to the authorities. So this was, I think, the first example of being able to use machine vision to do lice counting in the salmon and use that as reporting. Instead of having to take up the fish and count the lice, they could now just use the camera observation. And I think this is a great example, and it's going to come more things like this also for like welfare. They're going to, and it's going to be demanded, I think, in the future. So it's something to look out for. Um, here's I think one of my other great examples that I like to use both for as AI, but also robotics, because you are using uh, machine vision to find the lice and then shoot a laser and change the temperature in that lice for, in some milliseconds, just a small temperature change that kills the lice. And this keeps the lice population down as long as it's not an overwhelming amount. And then you don't have to treat the salmon. And this is, I think, a very cool example of AI for salmon anyway. And then you have like hydroacoustics, which gives you more of a population. Uh, so what's happening within the population inside my net? This is something a camera is not really going to give you. A camera will give you what's happening there, but here to combine it with what's happening with the whole population, will really be able to give you a better understanding of the fish and the differences between, let's say, loser fish or fish of different coping styles and how you might want to feed them that a camera would never be able to pick up. Um, Sensor globe is a new technology, and where it records. I'm going to jump to this. This is a series of sensor globes. It's called the crowding companion. And this could be used for any crowding of fish, no matter what. And it's measuring, in this case, it's measuring oxygen as a main, but they're going to have other things involved here too, with a light on top. So when you're crowding, you're actually, the net can be connected to winches, and you could automatically adjust how much you crowd depending on how this system is recording the oxygen level, for instance. And this is what the industry is starting to really take up now in Norway, and that's a combination of sensors and AI. Um, Aquatic code, I don't know if you're familiar with this, but here is a new uh, AI system for sorting your fish when you're moving from, let's say, one system to another. And this is mainly used now for salmon. And here um, they're sorting by gender, as an example. So here they're using ultrasound, and they are scanning each fish, and they're going to tell you if it's male or female, and they'll sort them. So they're making populations that go to sea that are all female, all male, because they have different growth rates, right? And because they have different growth rates, you can have more uniform populations as you grow up. So the slaughter time and this will be a little different. So you have more uniform in that context. But they can also, through here, they can start determining nephrocalcinosis and other issues that show up in the fish. Um, We've had a EU project, efficiency, and where we have Fish Talk to Me and the iBoss system, where it's very much how do you integrate um, the information from the biology of the fish. So you want the fish to tell you if I should be fed, but you have to also integrate water quality and other things to make some smart feeding. And in this case, this is an open source system that could be made for any kind of system. So a lot of activities are going on in this direction in different contexts. You have companies like Oxyguard's Covelia. They are all over the globe with all different types of aquaculture systems, from eel to tilapia to everywhere, and it's a system that brings all your data into a place, and you can do different types of predictions and things like this. So it doesn't have to be maybe some of the larger companies like Aqua Group that give you the all-in-one package. They do everything for you, or Scale have the same. Um, you can find a lot of these smaller companies that can give you just as much value for what you are, and with a lot less price tag. I use this slide sometimes just to show, the complexity of what the data of what a fish farmer in Norway would want. They would want all this. So S is status and T is trend. So they want to have this information all the time. But you can imagine that this isn't such a simple thing. And then they want to add AI to this. So to simplify and get the early warnings and this. They're not there yet, but this is their dream, is to be able to go in this direction. Um, like I said before, they're still trying to get all their data in a place where they can do it. And today, a lot of the problem also is going um, from IT, so from the data all the way down to the operational. So you actually can use both in more real time. Um, Here's an example of one of the projects we have going now. It's RAS 4.0, and it's sort of integrating a lot of the things I talked about. It's about feeding control, it's water quality control, it's energy control, and how you integrate all these to have the best system for the fish with the least or with the most sustainability. So there's still lots of challenges that we have today. Um, and some of these are the outdated sensor data standards, even that, but standards in general, data standards. And basically what you're saying there is, so if one farmer has a water quality sensor and he has it at 3 meters down, and the other guy has it down at 4 meters, and they don't have a standard, they might not know that they're at different depths. So they're trying to mix this data as the same. This is not good. There's a lot of industry fragmented digital infrastructure. That's what I was talking about before. Is um, some years ago, I was talking to Grieg Seafood, and they said we have 17 different systems that don't talk to each other. So how are you supposed to do anything with that data? Now they're moving it into one system. Inadequate real-time sensing and understanding of the fish biology environment. So we still don't have the AI that can really give us a lot of that, but it's coming. There's a lot of difference in digital maturity across farmers. This has an impact. Insufficient access to data from data sharing. This is what I talked about before. Prediction and decision tools, but also holistic data analytics for the industry. So for the sector in a country or in Europe or globally, all these different levels or a region, all of that matters to really understand what is going on. So I think this will help when we have better infrastructure and for that. Um, I don't know. Maybe I'm going over time. Not really seeing my clock, but I'm okay. I'm okay, Serge.
Fine, we're go ahead.
Um, so I think that for me, when I say scaling of understanding and applications, um, there are a lot of AI applications that can be for your site or from site to site that you have, or for a region or nationally. And it all starts with the data. I said that before, right? So really knowing what that data is and having applications that then can use that for your benefit, but also for your neighbor's benefit. Often you don't think about that, but actually these things can be really important, especially if we think that consumer confidence is one of our priorities in the sector, is that and more transparency is going to be required. So I think this is something that we have to think more about when we talk about sharing data with our neighbor fish farmer. That even if I do it good, you want him not to do horrible, because I sit in Sweden, so I live in Sweden, but I work in Norway. And when something bad happens in Norway, the my neighbor says, "Well, I'm not buying Norwegian salmon." They're not saying I'm not buying that guy's salmon. I'm not buying any of it. Right? So we have to think like that. AquaCloud is one of the ones in Norway that is gathering data, and I think they've done a great job in being able to start getting, I think they have half the production of Norway today. And they have sensor data, but also how the fish and when the fish died. So what's the cause of the mortality? And then you can start tracking this by region and time of year. And these types of things can be really useful for your planning. And now in Norway, you have all these different types of production systems, so you could manage this in a whole different way. You have companies like Manolin, and they do all kinds of, they help you get your data into a place, and then they can start uh, helping you with different things. So they have things like being able to look at disease spreading and where it is, or how you can check your protocols and make sure some things are better than the other. Yeah. So I'm getting close now to the end. So I think I'll go back to this. And so everybody should leverage digital innovations. I'm a believer in that. They don't have to be complex. It should be a good fit for what you do, and I think this is very varying. But I think there are a lot of different solutions and simple ones, or complex, depending. Um, and just my last my last slide about European Digital Innovation Hub, Oceanopolis. My role today is mainly helping SMEs and small farmers in Norway. So um, to either help them with their digital roadmap on building up their business models and what they need to do to help get into the market. But I also work with small farmers and how to help them figure out what do we need to do to be able to take advantage of AI. And we see, I've talked to many of these small farmers and say, we collect a lot of data and we do nothing with it. Nothing, zero. They collect a lot of data. Um, uh, and they have no idea what they should do, zero. So um, I'll end there and yeah, open for any questions.